All right, so today was day 45. I'm uploading in the morning because, yeah, I wasn't able to upload at night. But essentially, what I did was polishing. Okay, so I was doing a project about comparing two techniques: fine tuning, RAG. Well, three techniques: fine tuning, RAG, and prompt engineering, to understand like how well does it performs when it tries to generate um, uh, Cisco telemetry configurations, right? So what I did in the past days was like I had like a bunch of notebooks, and I tried to make them like as modular and as independent as possible. So I separate them into these like source code, right? And I created like scripts like to build like all the data and everything. And to today I focus mostly on creating the like the experiments. So I'm using MLflow, right? And now like all the experiments and everything, it's completely done, and it's very interesting. I can show you. So okay, I have to go into source, and then okay, I'm gonna open the dashboard. And as we can see, I have these two experiments. This one is to analyze like how well the rack performs, and this one, and the other one is for the fine-tuned models. All right, so let's see, for example, the which one. Let's see, for example, first the rack. So what I did was, let me show the notebooks. This is evaluation of the rack. So what I did essentially is that I created like a grid search, you could say, in which I'm able to test the RAG with two different vector databases. One, which is like a fixed window embeddings, and which I have like all the YANG modules, which are like specific documents for sensor paths in telemetry configuration. And I just take the uh, I just take like certain amount of characters for the embeddings, and in the other one I make like a smart search about it. Then I can use like a different parameter for top K, or for the temperature, or using a different chat model, right? I can even specify filters, but I don't do in this case. And then I run like all different configurations for different instances in a data set. And this is an example of what I get. I'm using as a score and LLM as a judge. So I have like this prompt, right? That looks like this. Generate a Cisco iOS XR telemetry configuration and so on, right? Use your PC with no TLS. And then it gives me like this answer, and this is the expected output, right? So I created also a dataset, and then I'm comparing this against a response, and then I'm using another LLM to, as you can see here, to give a score. So in this case, for this specific answer, it's saying that it's 0.3, the score out of 1, and it says the candidate config uses the correct IP, port, and protocol. However, sensor paths are mostly unrelated with the request, and so on. So that's why it assigns like a low score. And I get the scores for like all different configurations and so on. And in the end, I can see like the performance of everything. And of, I mean, and of as a summary, I can say that yeah, the model that performed the best, this is like the graph, it was using RAG with, is this one, using RAG without even prompt engineering, right? And with this model, the system prompt variant, that's like essentially it. And the fixed window also tend to perform better. Yeah. And yeah, that's essentially, I mean, that's what I did. And That's all.